We are in example 6 now, a simple mercury barometer. Now you should have seen the whole setup in the previous video already. Okay, so in part A it says sketch a mercury barometer and label its parts in the box provided. Okay, I just want to point out that when you are labeling, please make sure to label that this enclosed volume over here is vacuum, so there are no air particles inside. All right, and then you should have one long column of mercury, and then at the bottom you have excess mercury. We label it as a mercury reservoir. Now for mercury, the meniscus curve in the upward direction. Okay. Now part B, mark on the mercury reservoir a point P which experiences atmospheric pressure. Any point that is exposed to the atmosphere will experience atmospheric pressure. Okay, so up to you to choose any point along the surface. I will choose, for example, this point over here, and I'll label it P. Okay, feel free to choose this point, and this point. Okay. Now part C, mark in the mercury column a point X which has the same pressure as point P. If you all recall what you have done in your hands-on activity EO1, you'll see that whenever you have the same liquid, so for the same liquid, right, any level, or rather any point at the same level should have the same pressure. This is actually the key idea that we are going to revisit over and over again for the barometer as well as the manometer. So take note of this. Okay. So for here, mark in the mercury column, I'm just going to choose again a point that is along the same horizontal level. But in this case, because we want somewhere inside the mercury column, so we mark somewhere here. Okay, and then I'll just label this as X. So what is the reason? Reason is because point X is at the same level and they are of the same liquid, mercury, right? So point X is at the same mercury level as point P, all right? State the pressure due to the vacuum above the mercury column. Now, since this is vacuum, no air particles colliding with the mercury surface, right? So no force exerted here, and therefore pressure is equal to 0 Pascal or 0 cmHg. I'm going to do part F first. Mark on the diagram H, the height reading to be taken to measure atmospheric pressure. Now remember just now we mentioned that over here, this is where pressure is equals to 0 cmHg. So as you move down your mercury column, the pressure will increase. So for example, if I look at pressure here, okay, pressure at this point will be equals to, I call this H1, okay, will be equals to H1 rho G, and pressure at this point, okay, will be equals to pH2, okay, so H2 rho G and so on. So if I want to measure atmospheric pressure, I need to go all the way from the top, okay, to this surface over here, because remember we say that this surface is where P is exposed to the atmosphere. And therefore the height that we need to measure is measured from the surface of your mercury reservoir all the way to the top of your mercury column. Okay, so I'm just going to label this as H. If this column is H, then my pressure at point P, at point X, the pressure at X will be equals to H, density of mercury, and then times G, right? So in Pascal, it will be H multiplied by density multiplied by G. Alternatively, when expressed in cmHg, we can just look at this length and then replace this with cm of Hg. How many cm of mercury? All right. So this one can be expressed as Px is H cm of mercury, okay, or rho Gh in Pascal. Part G. Mark the points R and S to indicate the positions of maximum and minimum pressure. Now minimum pressure has to be 0, right on top over here where it is just vacuum on top of this point. And then as you go lower and lower in the mercury column, deeper and deeper, right over here, as the depth increases, the pressure will increase, right? So this is where the pressure is the highest, right? So let me label the points. Where is the maximum? I label as R. Where is the minimum? I label as S. So we are done with example 6.